In today's lesson, we'll be looking at equations of parallel and perpendicular lines. So if two lines with gradients m1 and m2, written like this, okay, with subscript 1 and 2, are parallel, then the gradients m1 and m2 must be the same, meaning that these two lines have the same direction only if they have the same gradients. So let's just say we pay attention to this little table here. If the gradient of this line here is number 2, then the gradient of a line that is parallel to it would also be 2. If a line has a gradient of negative 3, then the gradient would also have negative 3. And if the gradient of another line has 4 and 5, well, the gradient of a line parallel to it would also have the gradient of 4 and 5 as well. So, the thing to take away from this is that parallel lines have the same gradients. Now let's have a look at it if two lines with gradients m1 and m2 are perpendicular. Then, what this means is that the two lines here, they meet at 90 degrees. Okay? So the word we use to define two lines that are 90 degrees to each other is perpendicular. Now, whatever the gradients are, which are some particular number, they have to multiply to give you negative 1. Or m2, which is the other gradient, would be negative 1 over m1. So this means that the gradient of the perpendicular line is a reciprocal and opposite sign to m1. Okay? So, I'll give you a very simple example. If m1, this line, has a gradient of number 2, 2 is the same thing as 2 over 1. If we get the negative reciprocal of this, which means swap this around and change the sign, we will get the answer 1 over 2. Negative 7 is the same thing as negative 7 divided by 1. Simply change and find the reciprocal of this number and change the negative to a positive, and you'll get 1 over 7. If we find the gradient of the perpendicular line to this gradient, we would get this flipped around, so that would be 5 and 3, but it's made negative. So it'll be negative 5 and 3. Let's do the same thing to this number here, which is negative 2 and 9. If we find the reciprocal of this number, that would get us 9 over 2. Oops, I should use a different color. 9 over 2, but instead of a negative, we have a positive answer. Okay? Let's have a look at some examples on how to do these questions. Find the equation of the line that is parallel to y equals 2x plus 9, has a y-intercept of 4. So in context, if I was to just briefly sketch this out, which you don't really have to, the y-intercept was 9, and the gradient is 2. Okay, so a gradient of 2 means it has to go upwards. So it's something that looks like this, one of these lines. But that line has to intersect at the number 9 on the y-axis. So it kind of looks like this. Okay, so it's not fully drawn, it looks like that. Now there's another line that has a y-intercept of 4 that is parallel to this line, which means the line has to be looking like this. Okay, so it's the same direction, but it intersects at the number 4 instead. So how do we find the equation of this line? Well, we firstly know that the y-intercept is 4. Okay, cool. But we have to find the gradient of this line. So the gradient of this line is the number 2. So we can say m1 here equals to 2. So m2, which is the gradient of our red line that we're finding, is the same gradient as this line that we're finding, which is the number 2. So we say it's the number 2 as well. But the red line has a gradient of 4. So we say the b value is 4. Now remember how we said y equals mx plus b. So now we found out the gradient is the number 2 and the b value is number 4. So we can just replace those in, and our equation of the line will be y equals 2x plus 4. That's how you do part A. Okay, let's have a look at part B. Y equals 3x and has an x-intercept of negative 2. So, from y equals 3x, we can see that the gradient of this line has the number 3, okay, which means our gradient of our parallel line will also be 3, okay, and this line that is parallel to this line here has an x-intercept of -2, okay. So how y equals to 3x actually looks like, okay, it's a line that is the same thing as 3x plus 0. So the y-intercept is 0 here, but the gradient is 3, which means the rise of 1 is 3 over 1. So if I go right by 1 and up by 3, there's my new point, and I join that to make a straight line. So again, you don't really have to draw this, but just understand for context reasons that this is what it means. Now it says that there's another line that has an x-intercept of -2. That line that is parallel to this, okay, I'm just doing a rough sketch, it's going to have an x-intercept of -2 here. That x-intercept also is a coordinate. It is a point on the x-axis which is -2, 0. So, using our equation, y equals mx plus b, what do we know about this red line? We know that the gradient that we found out was 3. So we can replace m here by 3. So we get 3x plus b. But we need to find this b, which is the y-intercept, which is nowhere indicated in the question. But we can also find out this by making a substitution of x and y, which you have to do for all questions, and that's these two numbers here. So x in this case is -2, okay? So I'm going to replace x here by -2. I'll write that down like that. And y here is 0, as indicated by the second value of the bracket. Then we plus b. So now 0 equals to -6 plus b. And if we want to solve for our b value, you should know by now that if you move a -6 over to the other side to solve for b, then 6 would equal to b, or b would equal to 6 if we swap that around. So now that we found out what's our b value and what's our gradient value, we can now say that the equation of this line will be y equals to 3x plus 6 by using the gradient and putting that here and the y-intercept, which is right there. Let's move on to C. Y equals 5 minus x over 2 and passes through -1/6. Now, let's have a look at the gradient of this line. This line, this equation, can be swapped around like this so that it becomes minus x over 2 plus 5 instead if you swap around the two boxes that I've drawn, so that it's in the form of y equals mx plus b. Now, apart from that, there's an invisible 1 here, and that 1 with a negative over 2 can be slightly factorized out, so it looks like this. Okay? So that minus half x is the same thing as negative x over 2 anyway. It means exactly the same thing. So now we can identify what our gradient is. So m1, which is the gradient of this line, is -1/2. But we also want the gradient of our parallel line. Our gradient of the parallel line will be m2, also containing the same gradient, which is -1/2. Okay? So far, y equals mx plus b, which is our equation, has a gradient of -1/2. So we're going to replace that in. Okay? Now remember, to find b, we have to substitute some value of x and some value of y. Sometimes they're given the question, and in this case they have. So x is -1 and y equals 6. So if I substitute in y as 6 in there, and x is -1 in here, well then, I will get 6 equals -1/2 times -1 plus b. -1/2 times -1 is half. Okay? And if I want to solve for b, well, I have to subtract half to both sides so that these cancel. 6 minus half, let me just check on the calculator, that would give us 5.5 or 5.5. I'm just going to write 5.5 for now. And then here is my y-intercept, as well as the gradient that I need to construct my line that is parallel to this, but passes through -1/6. So, y would equal to -1/2 x plus 5.5. Okay? So in context, if I was to draw this out, okay, that line has a negative gradient and its y-intercept is 5. It looks sort of something like this, okay? It's not really 100% accurate, but there is my y-intercept of 5, and it said there's a line that passes through negative 1, 6, which would be somewhere around here, okay? Somewhere around there, okay? That is parallel to the other line, so it looks sort of like that, okay? And we just found out the equation of this line, okay? Let's move on. Question D. So, 2x minus y equals 6 and passes through 5, negative 2. So this is nowhere near written in the gradient set form that we love, okay, and can gather our gradient from. We have to rearrange this formula to make it y equals mx plus b. So if I write the equation out once and subtract 2x to both sides, so that I try to get y by itself, okay, it's always by itself. 2x minus 2x is 0. Negative y is left over from the left-hand side of the equal sign, and that is equal to 6 minus 2x, which is the same thing as minus 2x plus 6, okay, because that's positive and that's negative. And now I have this negative in front of the y, which I have to get rid of. So I'm going to multiply this by negative 1 to all values here, and that will give us y equals to negative 2x times negative 1, which is 2x, 6 times negative 1, which is negative 6. And so I have now found out my equation in gradient intercept form, where the gradient of this line is 2. So the gradient of the line that is parallel to this must also be 2. But that line also passes through this, okay? So we're going to make a substitution soon. Let's write down our equation for the line we're finding. Y equals mx plus b. M would be equal to number 2. So we're going to write y equals to 2x plus b. And the b, which is our y-intercept, is what we want to find. We find that by replacing x and y by these two values here. So those are these two right there. So if y would equal to negative 2, that's equal to 2 times 5 plus b, okay? So that negative 2 is equal to 10 plus b. And now if we subtract 10 to both sides, like how I've done there, then I get negative 12 equals to these 10s cancelling out. So you get b equals negative 12. So therefore, if I now get my final equation, which contains my y-intercept of negative 12 and my gradient of 2, then y equals to 2x minus 12. Okay? Let's go through E. Y equals to negative 5x minus 8 and passes through the midpoint of 3, negative 10 and negative 5, negative 6. Okay, that's a hard question. So, how would I actually do this? Well, I need the gradient first of all of this line, and that's easy because it's already in y equals mx plus b form. So m1 is equal to negative 5. So the gradient that I need is also has to equal to negative 5. But it passes through the point 3, negative 10 and negative 5, negative 6. Okay? So if I was to draw this line accurately, let me just show you what this means. So I've got a line here which is y equals minus 5x minus 8. Now minus 5x minus 8 looks like this. If I was to just extend this down a little bit more, and I say that negative 8 is here, exactly, okay? That is my y-intercept there, but my gradient is negative 5 over 1, which means I have to rise by negative 5 and run by 1, okay? So if I do that, that means that my line looks like this. I have to rise by negative 5, which means go down by 5 and go right by 1. So my dot will be here. And if I was to join that up to make a straight line, this is the line that minus 5x minus 8 represents. Now, the context of this question says that there's a midpoint of 3, -10 and -5, -6 that passes through. That's parallel to this red line. Okay, let me just draw that for you. So 3, -10 will be 3 to the right and -10 down, which is right there. Okay, and -5, -6 is 5 to the left, which is here, and 6 down, which is over here. Okay, so there's 3, -10, and -5, -6. Now what we've got to do first is find the midpoint of these two. Okay, we want to find the middle of these 2 points. Okay, so the midpoint, right, remember, is x1 plus x2 over 2 and y1 plus y2 over 2. So here's our x values, x1 and x2. Let's add them together. We would get 3 plus -5, which is 3 minus 5 anyway, over 2. And then we'll have our y1 and y2 values, which we'll also add together. So that's -10 plus or minus 6. So that's the same thing as -10 minus 6 over 2. Simplifying that down, 3 -5, 3 minus 5 is -2 over 2. -16 over 2 is there. So simplifying that down will give us -1 if we divide these two numbers. And -16 over 2 is simply -8. So now if I plot that on my Cartesian plane, wrong color, here we go. -1, -8 is here. Okay, it's this value here, right? So there's my midpoint so far. Just write that down, so that's my midpoint. Now what happens is that there is a line that is passing through this midpoint that is parallel to the first red line that I've drawn. And now our objective here is to find out what equation this line is. Okay? So we know first of all that this line, or both of these lines, have a gradient of -5 and a -5. But we're going to use this one here. Okay? Then y equals to mx plus b is the equation of this line, right? We're going to substitute in gradient of -5 in here, so that we get y equals to minus 5x plus b. But it has to pass through this point, which is the midpoint. That's what they said. So we're going to substitute in x as -1, y as -8. So y is -8, right there. Then you have -5 times x, which in this case is -1, plus b. Simplify the -5 times -1, which is 5, plus b. And if I minus 5 to both sides, like so, that 5 will cancel out. So that -13 equals b, and that means b equals -13. Okay? So, putting that all together, okay, let me just put this question away. If I put that all together, we've got that gradient of -5 there, okay, and our b value of -13. So therefore, our equation is y equals to -5x minus 13. Okay, that's the answer for that question. Let's have a go at F. Now, for question F, we've got 2y equals to x minus 3. This is not written in the form y equals mx plus b. And to write that in that form, we have to get rid of that 2. So we divide all those terms by 2. So that y equals to half x minus 3 over 2. Okay, so that our gradient of this line is now half, and the gradient of the line that we want that is parallel to this is also half. Okay, now y equals to mx plus b is the line that we're finding. It does contain the gradient of half here. So y equals to half x plus b. And all it takes to find our answer is to solve for b. In order to do that, we substitute in x and y here. So y is now 7, or -7, sorry. And that is equal to half times x, which in this case is 6, plus b. So that negative 7 equals to half times 6, which is 3 plus b. And if we minus 3 to both sides to try and find b by itself, then we get b as minus 7 minus 3, which is minus 10. And now my y-intercept and my gradient is ready for me to substitute back in here. So that y equals now half x minus 10.